Hello, good evening. This is Nas from NB Network Lessons. Hope everyone's doing okay and in high spirits. So, my today's topic of discussion is two ways to represent vectors in physics 1. There are more ways, but that is not part of discussion in physics 1. So, we're going to stick with how to represent two ways, and we'll show you the two ways how to represent the vectors. And this is, by the way, physics lesson number 11. If you recall from my previous lectures, I have discussed under calculus polar coordinates, Cartesian way, how to represent a point on x and y axis. For example, like this, you have y axis, you have x axis. This is the point. If this point right here is, let's say, 5, this right here is 4, the Cartesian way is going to be x, which is 4, y is equal to 5, okay? However, if you want to represent the same thing in polar coordinates, that's going to be basically like this. You have something like this. You have an angle, which is theta, and this r is the length of this arrow, and you will represent that at this point right here as r and theta, okay? If you are a little hazy on that, just go under my collections, click on calculus, and then search for polar coordinates and you'll find it. Thank you. Let me go ahead and dive into first way of representing vectors. The first way of representing vectors, you have y-axis, you have x-axis, okay? All right, you have an angle right here. You have a force right here. And I call this F1 vector because this has a length of an arrow represents the magnitude and arrow represents the direction. Okay. So in this particular case, just the key point to take away is that the angle this right here is always going to be with respect to x. In other words, you're going to always start measuring angle from x-axis up till right here. All right, let's say if this was right here, this force was right here, right, F1, then you will start from right here with respect to x-axis and go up till right here, okay? That would be your angle. So that's what I wanted to show you, that in physics, in calculus, in algebra, any subject, when you're measuring an angle, it's always with respect to x-axis like this. All right, now let's say you have something like this. You have y-axis, you have x-axis, okay, and you have a force which is going in this direction, okay. I call this f of f vector. So if I ask you, can you tell me what's going to be the angle? Can you show me the representation in graphical form? Yes. With respect to x-axis, boom, like this. This is my angle, all right? So this is one way of representing vector. Now let's go ahead and take a look at the second way of representing vector. Second way of representing a vector is what we are going to use mostly when we solve our examples. So let's say you have y-axis, you have x-axis, okay? And you have y-axis right here. You've got basically f of x, force which is going in this right here. It goes up till right here. This is f of x, all right? And then basically you have, let me actually draw this. So this is basically my vector f, okay? So this right here, this point right here is the length of fx component of this force, and this right here is the y component of this force, f of y, okay? So anytime when you have a force which is at an angle, right, it has an x component and has a y component, and you will see that in my upcoming lessons how we derive those. Angles, cosines, sines have to be involved. But as of right now, I'm just going to say fx. In reality, fx is equal to f time cosine of certain angle. Fy is f times sine of some angle, but I'm going to show you that in my next lecture with an example. So then we can say f is equal to fx plus fy. Okay, now keep in mind these are the components with respect to angle, both of them. So that's why it's okay to say that. Now in this case, another observation is that fx is equal to positive and fy is also equal to positive, right? Because it's going in positive direction and it's going from bottom to top. That's why it's in positive direction. Another example, you've got x-axis, you've got y-axis, and you have a force which is going this way. All right, it's a vector. All right, so now in this particular case, this right here is going to be my fx component, and this right here is going to be my fy component. This is basically shadow of y on x-axis. So now in this particular case, again, force is equal to fx, which is basically f time cosine of certain angle, plus fy, which is force times sine of certain angle. All right, put the vector sign. Another observation is that in this case, fx is negative, fy is also negative. As you can see from the graph, it's going in the opposite direction, going from right to left, and this is going from top to bottom. All right, my friends, that's all I wanted to discuss in this lecture. I will come back in my next lecture and I'm going to solve an example and it will clarify things for you. Thank you so much for watching. If you like the contents, please go ahead and give me a like. If you like physics, this is the place with me. Stick with me. I'm going to do my best to make you guys master by taking baby steps. Thank you.